So one of the things that we're always doing as math faculty members in college is we end up teaching a lot of students, particularly in general education, for whom they're having kind of their last formal exposure to school mathematics. That we would like for it, first of all, not to be their last. We'd like to be able to make the sales pitch for them to continue their studies mathematically. But second of all, students come into mathematics with a lot of beliefs about the nature of the subject and the sort of the epistemological foundations of the discipline that are not particularly productive to collaboration and to social discourse. And one of the things that I want to do, particularly if it's a student's last mathematical experience in the formal classroom, is to kind of convince them that it can be an experience that leverages the skills that they already have, can give them an experience of being social and collaborating and constructing knowledge as part of a community. Because what people think math looks like, right, is that they think that it looks like this sort of received wisdom handed down from on high on stone tablets. And they think that the process of doing mathematics is very solitary and it involves a lot of staring at blackboards with no actual English words on them, right? In fact, the classic story about Plato's academy is that there's an inscription over the door of Plato's academy in the original Greek. Roughly translates to "let no one ignorant of geometry enter," right? And so there's this belief that mathematics is this gatekeeping subject, and functionally that is how mathematics has operated historically in education, both K-12 education and in higher education, that it's a subject that has been used to set up barriers. It's been used to exclude a lot of students from the educational enterprise. And so you'll notice another thing too that is true about these "what you think math looks like" slides is that these are all, white dudes standing in front of this sort of mathematics. And so a lot of students really do struggle, and if you're watching this webinar, maybe you have in the past as well, to sort of see themselves as part of the discipline, right? Where do I fit in mathematically? And so the first thing that I have to do with my students is just to try to convince them that you, the student, can be a part of math. Because in reality, what mathematics looks like when it happens in my college classrooms and in an increasing number of college classrooms, and more to the point, what it looks like when mathematicians practice mathematics as professionals, it looks very different, right? It is inextricably a social enterprise. We do mathematics together as part of a community. We're involved in a peer review process. A theorem is not true because it's sort of handed down to us from some authority. It's true because our peers have reviewed it and said, yes, this meets our criteria, but that it's all a conversation. It's a collaboration. It's inextricably social. And students want that, moreover, right? They want their experience of math learning to be more collaborative. They want to be in conversation with one another. They want to have, as we think about in sort of humanizing online learning, they want to have both a cognitive and instructional presence. They want to interact with me, but they also want to interact with one another. They want to learn in community. They want to be able to plug in their language skills into mathematics, but that's a struggle for a lot of students because a lot of math courses have not historically asked students to wrestle with actual close reading and critical reading and using their own vernacular, right? And also that's kind of it's a skill that not only has it not been valued because it's not been valued by their previous math classes, it's something that we need to work on them to help to develop those reading skills. As Nate was saying, right, reading a mathematical text and extracting information from it, it's like reading a scientific journal article, right? It's sort of a domain-specific skill that I want my students to come out of my classes having developed and having had an experience of. So here's a little bit about how I do it. So sometimes I do it in the LMS, sometimes in Canvas, as Mary was saying before. Sometimes I've done it outside of the LMS. It really it depends semester to semester how much I'm actually using the LMS or not. But I sort of provide students with some reading question guidelines. Sort of what I find students are doing with the social annotation a lot is that they are asking questions and saying, hey, I read this passage, didn't really understand it, can somebody help me out? And I just try to give them a framework that helps them to make those questions as specific as possible. Sort of let us know what kind of feedback are you looking for, that kind of thing. And I also do a lot of encouraging my students to share other helpful resources inside of these annotations, right? To go out and research on the internet to find other resources that speak to the same material and kind of say, oh, I found that this was really helpful. So my students do a lot of sharing of videos and other links and sort of rich content inside of the annotation space to really add value to what's already in the textbook. And particularly now that there's a lot of relatively new and really high quality open educational resources available around especially introductory level college mathematics, that, you know, it's really the material that's out there is more than sufficient for any student who needs to understand a particular area of math to find what they need. If they don't find it in the textbook I've assigned them, they go find it somewhere else and they tag it right into the annotation. So I like to think of it as there's a framework that Benjamin Dickman, he's a math teacher who's currently developing a social justice-oriented Algebra 2 curriculum for high school, which is a fascinating project. You can find him on Twitter at Benjamin Dickman. But the framework that he likes to think of mathematical discourses happening in his classes is called notice, feel, wonder, and act. All right? These are the things I want my students doing when they engage with mathematics material. I want them to notice things. I want them to sort of acknowledge and experience the feelings and emotional part of doing mathematics, because let's face it, particularly with a lot of students who come into my classes with math anxiety and math avoidance, that they have a lot of sort of emotional, they have an emotional discourse that happens with the subject and not just an intellectual cognitive discourse. And so we want to give space for students to feel certain ways around math as well. And I really want students wondering, right? I want them to try and anticipate the next steps and say, well, how does this connect with this other thing? Where is this going? I want those kinds of questions happening in the annotation. And then fourth, action. So how is what I'm reading in my math textbook going to help to inform what I do next, whether that's something I do in my life or whether that's something I do in my course to help me to learn later on. So what I'm going to show you are just a couple of snippets and screenshots from my pre-calculus course that I taught using social annotation last spring. And so this is a course that was populated with mostly freshman and sophomore level students. Because it's pre-calculus, most of them are in the sciences and mathematics. I got a few students from the College of Business, but mostly these are STEM students who often come in believing themselves to be sort of strong agents of mathematics, but not necessarily having command of language in reading and writing and so forth. So I like to think that this was also a way to help to build those skills with them as well. So on the notice side, what I saw students doing is that they'll sort of consume a theorem and say, well, is this, I noticed that this theorem means this thing to me. This is how I'm reading it. Is this how other people are reading it and experiencing it? Can I understand it in this way? One of the things that's true about a lot of mathematical and scientific writing, I think mathematical in particular, is that, you know, a lot of authors are very terse. They'll say in one or two sentences what probably would take a paragraph or two to really fully explicate. And so the more we can get students to notice what's in the writing and to add to it in the margins, the more that they begin to understand what it is to read a mathematical text and to unpack the large amounts of meaning that are hidden in small amounts of prose. One of the feeling things that I noticed, so this student says something interesting. I've always found the vertex formula for parabolas amusing. I want more of my students to find mathematical ideas amusing, the way that this student did. But she found it amusing because of the different connections she was able to make between this particular part of it and the other ways of understanding. So her sort of mental scaffold was filling in. She was making connections between different parts of the material, and that was a good feeling for her, right? And so I want her to be able to experience and validate those feelings, but I also want the other students in the class to see, hey, you know, mathematics can be an experience that's full of positive emotions in addition to the ones that you might have brought into the classroom. So the feeling step, I think, cannot be shortchanged, should not be shortchanged in the process. Then there's the wondering element. This is probably my favorite one of the four, because this is really, I think, the most, what I feel mathematics research is for me when I do scholarship as a mathematician, is it's full of this sort of wonderment, right? Where you have a mathematical idea in front of you and say, well, I wonder if it works this way. I wonder if this thing is true. Because the fact is, as a mathematician, the theorems that we discover and we prove, right? We get this gut feeling that they're true long before we actually have a proof that they're true. And so most of what I do as a mathematician is wonderment, and then from that wonderment, trying to chase down whether or not my suspicions are actually true or not. So this student says, well, would this definition I'm reading of a function also apply for an inverse function? Does it also work this other way, right? So kind of pushing beyond the boundaries of what's in the text to other ways of interpreting or next steps that students might go to. And then there's the action step. So I thought this annotation here was a good example of an action-oriented one. So this student reads this paragraph about transformations, sort of gives some practical strategic advice for how to do a particular mathematical task. The student says, well, should I just use this as my strategy? Is every example going to work this way so that I don't have to, expend a lot of cognitive load trying to figure out what framework to fit the next set of examples in? Can I take this to the bank and run with it, right? To me, that's kind of an action-oriented way of experiencing the text. So that's as much as I want to say, and I want to leave some space for questions, but I really find that the experience I want for my students to have of each other and of the material and the experiences with me are collaborative, they're conversational, they're social, because that's how I experience mathematics as a professional. It's how I want my students to experience it as students as well. So yeah, thanks for having me.